So good old factorising, such an important skill when it comes to our algebra. Okay, first thing you always do, look for a common factor. It's the most often forgotten thing, yeah? But look for a common factor first. Then the number of terms it has is like a clue on how to approach it. If there's only 2 terms there and there's no common factor, what could it be? Maybe it was the difference of 2 squares, because when we did those sort of problems we ended up with 2 terms. So maybe that's what I'm looking for. Could be some difference of 2 cubes. We'll talk more about that later. If it's got 3 terms, what sort of questions ended up with 3 terms? Those trinomials did. The quadratics, x squared plus 5x plus 6, those sorts. So maybe it's one of those sort of questions. 4 terms. Technique we often try is grouping in pairs. Sometimes you don't find something in common with all 4 terms, so you just do a pair at a time. So alright, an example of a common factor. Remember, factorising simply means dividing by the common factor. And some people get confused with, what do I leave inside the parentheses? And if you're ever unsure, just say, oh well, I'm going to divide this term by whatever I'm putting out the front. It tells you what's left. So here's tricky. What do they have in common? I wonder. Oh, x. So we take the x out, and inside we're left with the a plus b. 5x squared minus 10x. I highlight that one there because sometimes people forget the 5 and leave 5x minus 10 inside. Sometimes people forget all the common factors you want to draw out if you can. 4 terms, hang on. There's that grouping in pairs idea. Because I'm looking at it going, oh look, first 2 have x, the others don't. 2 of them have got y, 2 of them have got m, no, still no good. 2 of them have got n, still no good. So do it a pair at a time. First one's got a common factor of x. Second one, notice I took out the negative common factor there, because we want to leave what's in the parentheses there. Ideally we would like that to be the same thing, because then I can look at this and go, hey, I've got 2 terms and there's a common factor of m minus n. So we can pull that out, m minus n, x minus y. Difference of 2 squares. It's just the backwards of the expansion we saw before. So you look at it and go, common factor, nah. 2 terms, can I write this? Again, this is more a thought process in your head. You'd look at it and say, yes, the first one's 4x all squared. Second one's 1 squared, so I can write this as 4x minus 1, 4x plus 1. It doesn't really matter whether you put plus or minus first. Technically though, minus I think should go first. But that's more to do with further expansions down the line, which we'll come to. So 3y squared minus 75. Hang on, 3 is not something squared, because there's a common factor. Pull the common factor out first. Now you got your difference of 2 squares. There they are. 4 terms, grouping in pairs question. Alright, I'll look at the first 2. 5 outside x minus y. Second 2, difference of 2 squares. Look, I've now got 2 terms. They've both got x minus y in them. That now becomes the common factor. This is the one where sometimes people go, what do I put inside? Remember, it's division. So 5 outside of x minus y, you're dividing by x minus y, you're left with 5. X minus y, x plus y, you're dividing by the x minus y, you're left with x plus y. The monic quadratic, the easiest of them all. If you expand out your binomial, you'll end up with something like that. This is why we say what multiplies together, you get the last number, what adds together. That's basically the idea. So we're looking at this and saying, what multiplies together, you give 18, adds together, you give 9. You come up hopefully with 6 and 3. So you know, right, x plus 6, x plus 3. Multiplies together, you give 3, adds together, you get negative 4. There's all sorts of information here. You know it's going to be 2 negative numbers. Right? Multiplies together to give a positive. So they've got to have the same sign, but they add together to give a negative number. Got to be 2 negative numbers. So negative 3 is prime, of course, so that makes life a lot easier. So minus 3, minus 1. But those sorts of things you think about, right? Think logically. If it multiplies together to give a positive number, they must have the same sign. Multiplies together to give a negative number, they must have opposite signs. Now, first time people see one like this, they get thrown because of the y squared. So, well, hang on, there's more than one pronumeral. How can this be a quadratic? It still is. You can decide what you want the pronumeral to be. Let's pretend the pronumeral is x. So now I'm saying what multiplies together to give 4y squared, what adds together to give negative 5y. And in fact, I don't really need to worry about the y's. They'll sort themselves out. It's the numbers that are the key. Multiply together to give 4, add together to give negative 5. Again, I'm looking at two negatives, and it'll be negative 4 and negative 1. But when I write it down, it's going to be negative 4y and negative 1y. I put down there. I mean, no different. Okay, splitting the middle. One's like this. Now, there are different ways of doing it, and again, I don't know how previous teachers have taught it. Most common way people have shown, I think, is with the cross method. Is that how most people would have, factorised these? The good old cross method. I like splitting the middle because it just keeps the same idea of what multiplies together to give, what adds together to give. I don't have to think any differently. So if I want to do this one, I say, what multiplies together to give? Not negative 7. But what we do is we multiply the constant by the coefficient of x squared. So I'm going to say, what multiplies together to give negative 21 and adds together to give 4? So adds together to give 4. They're going to be different in sign because it's going to multiply to give a negative number. We know the positive number is going to be the bigger number because they add together to give a positive. So I'm now just looking at two numbers with a difference of 4, multiply together to give 21, got to be 7 and 3. So in this case, positive 7, negative 3. And what we do, and the reason it's called splitting the middle, is you physically split the middle term into those two numbers, negative 3x plus 7x, and it becomes a grouping in pairs question. And so the first two has got a common factor of 3x, next two common factor of 7. Oh look, common factor of x minus 1, there's our factorisation. So I kind of like that because, as I say, it keeps the same idea of what multiplies together to give, what adds together to give. Let's just do another one. So in this case, not negative 12, but what multiplies together to give negative 24, adds to give negative 5, multiplies to give a negative. So again, we're talking about a positive and a negative. This time the negative one's got to be bigger because it adds to give negative 5. So a difference of 5 multiplies together to give 24, got to be 8 and 3. So we'll split it into minus 8x plus 3x. And again, we can now group in pairs. And there we have it. Alrighty. Away we go. Enjoy.